In this lesson, we'll be coding our first game. It'll be a very simple game. Orbs will spawn over the display, and we'll click them within a certain time period in order to win. So we have to get rid of all the orbs before the timer at the bottom right runs out. If we don't, we'll get a fail condition and we can no longer click the orbs. If we succeed, then we'll get a win condition. Okay, so let's get started. First thing we'll do is code our constants. So we need _h equals display.content height and _w equals display.content width. We're going to need a few globals to store some values and also to check the values over time to determine the state of the application. So these values will be O, which will stand for the total number of orbs on the display, and also time remain, the amount of time remaining in the game. This will be seconds. Time up, which is a state to indicate if the player has any time remaining. At the start of the game, it'll be false. We'll make it turn true later. The total number of orbs to render to the display, and whether or not the machine is ready to take user input. And that'll be a Boolean. Okay, let's store the math.random function. All right, and if we relaunch, nothing happens, nothing should happen. We haven't written any code yet to render to the device. Okay, so let's prepare our sounds. These are the sounds that will be used during the game. So there's our soundtrack, which plays continuously in the background. Load stream, and we use stream because it's a longer file. Media/soundtrack.caf. There's the popping sound, local pop sound. Audio.load sound, not stream. Media/pop.caf. Then there are two other sounds, local win sound equals audio.load sound. And this will be the sound upon success. So if we win, media/win.caf, and then the fail sound. And this will be the sound that fires if we don't succeed and we fail. Load sound. Media/fail.caf. Okay, so now all of these sounds are prepared. I'll go ahead and comment this code. Prepare sounds to be played or accessed. Okay, and these are our constants. There we go. Okay, so we're going to need to spawn the orbs. And so I like to work backwards from the goal. So I know I need to spawn them, which means I need a timer. TMR equals timer.perform with delay. I want them to be very fast, so 20 milliseconds between calls, and then spawn orb. And we're going to feed the total number of orbs we want spawned into the argument that receives how many times the timer should iterate. Total orbs. Okay, now let's create the spawn orb function. Local function spawn orb. And I'm going to copy and paste some text. If I had to type out all the text in the movie, it would take a long time to get through it. So through the magic of copy and paste, I'll select some text off screen and then paste it. We've seen this text before. It was in our timer movie. I am creating an orb variable and loading an image rect into it, setting its reference point, and then using mrand to randomly position it on the screen within a boundary that is the center of the screen, 50 pixels padding on all sides. So far, so good. We should be able to at least see this much if we relaunch the device. And there we go. Each time we relaunch, the orbs will render in a different place. Okay, now we're going to do a few more things to the orbs. We're going to make them clickable and as well enable some sounds. So now within this spawn orb function, we will make the orbs touchable. Orb add event listener. And we want to listen to the touch event. And we want to call the orb object itself. Now we need to create function orb touch and feed the event object into it. And here, if e.phase double equals ended, oops, let's put that in a string, ended, then, well, if we touch the orb, what do we want it to do? Let's comment right now to ourselves that we want it to play the popping sound. So to do that, that'll be audio.play, and now we feed the reference, which is pop sound. Okay. Let's relaunch it. Okay. We also want the orbs to disappear. So we'll remove the orbs. And for this, we're going to create a method called track orbs, which will keep track of the orbs in the game, and we'll feed self. Remember that the reason we can feed self is because this method is being called on the object, so we can use the self keyword. So we're actually feeding the orb into track orbs. Okay, well now that we've created a new method, we need to actually define that method. So before spawn orb, let's create a method, local function track orbs. And we'll feed in the argument obj, which is an object. Remember that we're feeding the orb into this method. We want to really avoid actually directly referencing the variable. Instead, we want to feed references to it via these function arguments and then affect them that way. So local function track orbs, parentheses obj. And when we click the orb, or touch the orb rather, we want it to play the pop sound, which we took care of, and then we want to remove it. So obj : remove self. And this will remove it from the display group. It'll free up some memory. You see here how when I clicked two that were overlapping, they both disappeared. We need to take care of that. So let's go back to the touch function, which is here. And within this function, we want to type return true. This will stop the bubbling so that the touch stops at the top layer. Okay, so if I click that one, it doesn't actually bubble down to these other two. So far, so good. I've got the orbs being removed as I tap them, and the pop sound is happening. Excellent. Okay, so the original game also had some displays. It had in the bottom left corner the state of the game, so if it was waiting or if the player could go, and then as well success or failure. And in the bottom right, it had a timer. So let's go ahead and create those text display objects. Again, through the magic of copy paste, I will copy some code, go over it, and we'll move on. Okay, so now I'll paste display underscore text. This is the text that will reside in the bottom left of the screen. So it's down here. And then I'll copy and paste the countdown text. Okay, same thing here. This text appears at the bottom right of the screen. And so this will count down, and we'll have a limited amount of time to actually select these orbs. A few things to notice. Notice that for countdown text in the new text constructor, I fed in the time remain variable. This variable here stands for how many total seconds we have, and then we're going to decrease that amount with a timer call. Okay, so let's go ahead and take care of that particular aspect now. What we'll do is we need to track the states of the game and call certain methods at certain times. Here we're going to need to call a timer that is going to every second decrease the time remain variable. To do this, we're going to create a method called countdown. We'll create it in between track orbs and spawn orb. Local function countdown. And we'll feed E into it. Okay, so what this method will do, every time it's called, it'll take time remain and decrease it, equals time remain minus 1. And then we will update the text appropriately. So we will take countdown txt.text equals time remain. Now we're only defining the method that needs to be called on the countdown. We haven't actually called the countdown timer yet. To do this, we'll go back into the spawn orbs code. This code right now is set to run every 20 milliseconds and spawn the orbs. What we'll do is at the end of the code, we'll keep track of however many orbs have been spawned. When they've all been spawned, we'll create a timer. So then if, let's put the end, if O, which is the total number of orbs, not 0, but O, double equals total orbs. Okay, let's go back to the top. O is 0. The total number of orbs we're going to generate is 20. So if we generate 20 orbs, then we're going to create a new timer. Game timer, or TMR, that's an idiosyncrasy of mine, equals timer.perform with delay. And every 1 second, that's 1,000 milliseconds, we'll call the countdown function. And we'll call it 10 times. Okay, well that makes sense because if we're calling this every second, then we'll have a total time of 10 seconds. Now, we wouldn't want to link this up to time remain because that variable is changing. So we want to actually hard code 10 here. We could create a constant that was total time, but we'll just go ahead and code 10. Now, you're probably wondering, well, what about O? Because right now, O equals 0. So when we spawn the orbs, what we need to do is we need to increment orbs, or increment O. So every time we spawn an orb, we need to increment O by 1. Okay. Okay, and then here, if all orbs created, start the game timer. Okay, let's relaunch it. Let's see if we have any errors. They're all created, and now you can see that the game timer is decreasing. So I could pop the orbs, and the idea is that when I get to 0, well, I shouldn't be able to pop any more orbs. As well, while the orbs are populating, I shouldn't be able to pop them too. So let's handle those two aspects of it. Okay, so I want to use this ready variable to track the state of the application. What I want is for ready to be true when the application is ready to accept user input. Otherwise, false. So user input here is determined by add_event_listener. So I'll take this portion of the event listener, which is the actual touch portion, and I'm going to put it within another condition. If ready equals true, then we process the touch, end. So now if I relaunch this, notice how I can't touch any of the circles because I've yet to set the ready variable to true. So at some point we need to set ready to true. Well, because we're calling the game timer after all of the orbs are created, and that is calling countdown, what we'll do is within countdown, we will call ready equals true by doing the following. If, then end. And here, if time remain double equals 10, then ready equals true. What that means is the first time countdown is called, time remain is going to equal 10. So we're going to fire ready equals true. We don't need to continually set ready equal to true. So that's why we're doing it this way instead of just setting ready equal to 2. Because remember that countdown is being called every second. Okay, we'll save it and relaunch. And now we can pop. If we go back, we try to pop, and then it's enabled. So far, so good. We need to also change this wait state so it says go and then win or fail. We need to probably implement this ready true, ready false in a few different places. One of the first places I can think of is back into the spawn orb method. Down here where we are creating this timer, remember that this entire code block is firing with spawn orb. So to be extra redundant, instead of saying if O equals or double equals the total orbs, let's do this. If O double equals the total orbs, start the game timer. Else ready equals false. This is a way to be absolutely sure that while the orbs are spawning, ready is going to be equal to false. Let's take care of the state in the bottom left corner. So that's the text here that says wait. Okay. So we want it to say wait, go, and then if we win or lose, it'll say win or fail. All right, so we are going to change the state of this by going to countdown. And just as we said ready was true with the first calling of countdown, we can change count down text or txt dot text equals string go exclamation point. Okay, incrementally test it, and it didn't change. So let's make sure that we did this properly. Ah, I know, wrong variable. It's display underscore txt. Relaunch it, and there it goes. So now it's ready. We're close to finishing. We just need to implement now our success or failure, and as well implement our soundtrack. So for success or failure, basically the player wins if all of the orbs are removed before the timer is at 0. So we need to code it some kind of condition that's going to track the orbs and then change the success or failure, and as well stop the timer. Because you don't want the timer to keep going if the player is done and there's no other orbs to remove. So there are two places where we're going to track win or lose. And that is within countdown and also within track orbs, because it's possible for the player to win the game before the timer's up. So we would track that within track orbs. But then also it's possible to check win or lose at the last minute within countdown. So first let's deal with track orbs. Let's do O equals O minus 1. What we're doing here is we're removing the orbs, and then we're decreasing the total orbs that are in the display. Okay, so the idea is that when O gets back down to 0, that means there's no orbs left. So if O double equals 0, then we'll want to play the win sound, and we'll want to stop the game timer. Okay, let's take a look at it. Let's do it fast, make sure we don't lose. Woohoo! All right, so we played the sound and now the timer stopped. When you have, when you're tracking win or loss and the state of anything, it's good to have a method also that's going to do some cleanup upon the state changing. So let's create a method called win-lose. Okay, so I'll create there at the top local win-lose, and essentially I'm going to feed it a condition. Remember that when you're dealing with methods, this could really be anything. This for me is a way to understand the purpose of the argument within a method. Okay, so if condition double equals win, then else if condition double equals fail, then end. So if it's a win condition, we'll change the display underscore text dot text equals win exclamation point. If it's a fail, display underscore txt or text dot text equals fail in capitals. Okay, so now we need to call the win-lose condition. So this portion here, within track orbs, if all the orbs are removed from the stage. Let's say display. Sorry, that's my action script coming out from the display. Then we'll call win-lose, and we'll feed win into it. Okay, so let's back up a bit. Every time we click an orb, we're calling track orbs. The orb is removing itself from the display list. The O variable, which keeps track of the total number of orbs, is decreasing by 1. And then a condition is being tested with each call of track orbs. If O reaches 0, that means all of the orbs are removed from the display. Then we'll play the win sound, we'll cancel the game timer, we'll stop it, and as well, we'll display win. Okay, the only problem with that is it is possible to win after the timer has stopped. Let's take a look. Oh, looks like we've got an error. Let's sleuth that. Line 28, error near if. Oh, I forgot the function keyword here. Local function. Okay. So the game starts. The timer is decreasing. I'll just take my sweet time. So now I can still pop the bubbles after the timer's up. I shouldn't be able to do that with this game. Woohoo! Instead, I should only be able to pop the bubbles so long as the timer isn't 0. Okay, so that means we need to keep track of whether or not time is up. So to do that, we'll go to the countdown function, because the countdown function is primarily responsible for keeping track of time. And here's what we'll do. If time remain double equals 0, that is, there's no time left, then time up equals true. Now this time up variable we declared towards the top of the script. Okay, so it's a state variable. Right now it's false because when you start the game, you're not counting down time, so time's not up. But here, we run out of time, time up equals true. Okay, well then what we can do is go into the track orbs condition, and we can surround this condition, which tests for all orbs being removed. Basically what we'll do is, before we even call the condition, we'll make sure time's not up. If time up does not equal false, then. So long as time is not up, and. Actually, sorry, true. So long as time is not up, because when time is up, time up will equal true. So long as time's not up, then we should be able to check for the number of orbs and play the conditions. So let's take a look. Okay, time is running. I'll take my sweet time. And I'm going a little too fast. And I can still pop them, but notice how I didn't get any win conditions. Okay, so that means we need to apply this if time up doesn't equals true to the touch events also. So we'll take this line, and basically we'll take the touch portion where we are testing for the phase is ended and all of that, and let's indent it. If, oh, I could just paste it. So if time up doesn't equals true, then we can actually go through the motions of popping the orbs. Save it, relaunch. Okay, I'll go a little slow. And now I can no longer click. So we're doing pretty good. We've got almost a complete activity. We're not going to implement any scoring here, though you could figure out pretty easily how to do that. Okay, so we need our background music, and that'll be pretty easy to create. So audio.play soundtrack, comma, create this table, and do loops equals -1. And we have yet to implement the fail sound, and also the win condition isn't as tight as it needs to be. Okay, so let's first see what we got. Oh, looks like there's a mistake. Oh, yes, we want the audio to play when countdown starts. So we can go up to here, just as we're setting ready to true and display underscore text to go, we can set the audio to play soundtrack. And let me make sure, yes, soundtrack. Ah, I see. They're missing a D. Okay. Okay, and then we go and click the orbs. Okay, so now we need a fail sound, and of course I don't have a stop yet, so let me comment this out. Okay, so we need some test for failure, and we'll test for failure by, within the countdown method, creating the following condition. If time remains double equals 0, then time is up. Well, obviously, when time is up, you want to check if there are orbs on the display. So, if, then, and end, if O doesn't equal 0. So that is, if there are still orbs on the stage, remember that O is tracking the orbs. That means that, well, we failed. So audio.play fail sound. And then we need to set the text. Display.text equals fail. And we need to set ready to false. Okay, let's check it out. Oh, looks like the soundtrack's not playing, so let's go back. Oh, it's not playing, of course, because I need to uncommon. And then we hear the fail sound. Let's try that again. Okay, so we'll play. And now we'll hit 0 with orbs left, and there's a failure. Let's try it again. This time we'll achieve a win condition. And the timer stopped, so we won't get failure. And I didn't code an audio stop. You could do that with changing levels. I'll just leave it playing. Okay, so let me disable that. Okay, so with this type of approach, we can actually easily change the total number of orbs just by changing the variable at the top. If we wanted the total number of orbs to be 50, save it and relaunch. Let's go ahead and comment the audio back in. And now this becomes a difficult game. You gotta really get the orbs as fast as possible. I haven't been able to do it yet. Yeah, 10 seconds, just not enough for all those orbs. But this is very similar to some of the bubble wrap games that you'll find in the App Store. You know, they're fun games. They're very easy to program, as you can see. We're going to get the fail here in a minute because I relaunched it without the sound, and then it's going to give us the fail sound, which is pretty good. And if you're curious to know where I got those sounds, in case you didn't figure it out, I just recorded them myself. Okay, so I'll give you an overview of this code. It's pretty large, and it's a lot to take in. Okay, so first we declare these constants. We do these two constants all the time, which are the display height and width. We cache the math.random function, because we're going to use it over and over. And then we created some globals here to keep track of a few things. O is for however many orbs there were on the display. Time remaining was a number to count down from in terms of seconds. Time up was a state. So was the time up in the game? Since we start the game with the time not being up, we set it to false. And then total orbs is however many orbs are rendered to the display. Set that back to 20. And then whether or not the app was ready for user input, that was ready equals false or true. At the start of the application, we don't want the user to be able to touch the orbs, so we set that to false. Next, we set all of our sounds to be readily accessible or played from memory. And there was a typo in one of them that caused us to have a pause, but that was just leaving out the D in soundtrack. We also created some other display objects. So the display underscore txt, which was in the bottom left of the screen, and countdown txt in the bottom right. Display txt was for displaying the current state of the app. So if the app was waiting, if it was ready to go, if you had won, or if you had failed. Countdown txt was a timer that every second would count down from 10, 9, 8, and would decrease down to 0. Okay, so the first thing the app does after loading is it spawns orbs. And that's this last line of code here. TMR equals timer, and then perform with delay. And every 20 milliseconds, it runs the spawn orb block and does it for the total number of orbs, which remember is here at the top, 20. Now we take a look at the spawn orb function. It's pretty meaty. And here we're creating an orb. It's a new image rect, and we're instantiating it at a random x and y, but within a certain range. Also, each orb has to have some amount of functionality. So we add an event listener for touch, and we put the listener, or the method that is called at every touch on the orb itself. Now, it gets kind of complicated as we implement our game logic. At the core, when the orb is touched, the following happens. A popping sound is played, and then we have another method that's tracking the orbs is called. However, we don't want the orbs to be touchable if the time is up for the game. That is, there's no more time left. But we only want them to be touchable when the game is ready. Okay, so that's why there's some multiple conditioning here. Okay, so when we spawn the orbs, we are also keeping track of O, which is increasing for every orb. That gives us all the orbs created. And when they're all created, then we're starting a game timer, which is firing countdown. And it's firing at 10 times at 1 second intervals. Okay, so then we move to countdown. And every time countdown fires, the following's happening. The first time it fires, we're setting the ready state to true, so now the game is ready for user input. We're changing the display text to go, so that's a visual indicator. And then here commented out only because I don't want it running in the background. Here, I'll go ahead and comment it back in. We're telling the soundtrack to play and to loop infinitely. Okay, so now we need to decrease the time remain variable by 1 with each calling of countdown. And we need to display that decrease in the bottom right of the screen. When the timer reaches 0, then we need to basically code the game over state. So time up equals true, so that's a state that's tracking if the time is up or not. Up to this point, time's not been up because time is counting down. So time up is true. And then we're saying, okay, when there's no time remaining, are there any orbs left on the display? If so, we're going to play the fail sound because that means that the user didn't touch all the orbs. We'll display fail in the bottom left of the screen, and we'll set the ready state back to false. This means that the app is not ready for user input, and we have a few other pieces of code that are dependent upon that, such as the touch portion of the code. Here, if ready is false, we can't actually tap the orbs. Going back to the orbs, each time an orb is tapped, then we're calling track orbs, and we're feeding self into the orbs. And we can do that because the touch event is being handled by the orb. That allows us to use the self keyword. We'll go to track orbs, and here I am feeding in the orb into the method. Every time an orb is tapped, it's removed from the display. That frees up memory, and we decrease the counter that's keeping track of the orbs. Now, if time is up, or if time isn't up, and the orbs reaches 0, that means that we were able to tap all of the orbs before the time ran out. So we'll play the win sound, we'll cancel the game timer, and then we'll call a cleanup method called win-lose and feed it the win state. This cleanup method takes two different arguments, win and fail. If it accepts a win, we change the display to win, and as well, we change the if it's failing, we change it to fail. If you had multiple levels, this is where you could code all sorts of cleanup to change levels or change difficulty depending on the user's input. Okay, and in a nutshell, that gives us the entire app. When you break down a game, you have to break it down in terms of turns here with this kind of game. And then the turns are systematically addressed given bits of code. And also what you noticed in this particular game is the heavy use of states, this ready state and the time up state, because different conditions would fire according to the states.